Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, you all know that yesterday we conducted the two unit tests. One is on mathematics and second one is on science, right? And the chapters were number systems from mathematics and motion from science. Now, I am going to show you the question papers. Please take the screenshot of those and use them for practicing. Okay. Dear students, this is maths question paper and it was conducted for 25 marks and it consists of total 14 questions. You can go through them. Yes, take the screenshot. And this is science question paper and it was also conducted for 25 marks and total number of questions 14. Go through them. Yes, take the screenshot or else you can go for copying the questions. Dear students, today we are going to start a new chapter in mathematics and the name of the chapter you are only going to tell how, because I am going to give you some of the information related to it. Observe and based on that, tell the name of the chapter. Okay, dear students, for this chapter, I am going to give you some of the basic information, basic terms. First one, here we are very familiar with numbers and different types of numbers which we have already discussed in the chapter called number systems, right? Now I'll take some of the numbers like 5, 11, 2 by 7, minus 15 by 2, then root 11, is it not? Many are there. And here you can notice that in this both rational and irrational numbers are there, right? Then what is the special characteristics of these numbers? It may be rational or irrational. Observe here. 5, it has its own value. Is it possible to change the value of 5 as 10, 15, 2, 6 and all? It's not possible. It has a fixed value. So that value cannot be changed. Even you can go for taking 11 also. Then what do you call a mathematical term that has fixed value which cannot be changed? It is called, yes, you are right, it is called a constant. And these are all some of the examples for constants. Now let me go for writing the definition of it. What is the definition? A mathematical term that has fixed value which cannot be changed, is called, what it is called a constant. And these are the examples for constant. Let me go for taking the second term. For this, I'll give you a simple situation. Assume that once in every week you will go to a fruit shop. There you will buy some of the fruits. Assume that in the last week you had bought 1 kg of apple and the cost of 1 kg of apple, it was around 105 rupees. And this week also you have already assumed that you have already gone to that shop. Again you have bought 1 kg of apple, but today it is about 95 rupees. Got it? Observe here the quantity is same, 1 kg of apple only, but the price of the cost of 1 kg of apple in both the ways it is varied. First it was 105, now it is 95. So there is variation in the cost of 1 kg of apple. That variation can be represented mathematically with a term. Do you know what is the term? And that term is known as variable See, in that only meaning is there. Variation. Then what are the examples? Before that, just I'll continue this situation. Next week you have a plan to buy again 1 kg of apple. What may be the cost? Do you come to know what it will be? No, it's not possible. So it is an unknown quantity. I take this as rupees X. 1 kg of apple. Next way it will be rupees X. So to represent the unknown quantity also, we go for using a mathematical term that is called variable. Clear? Hence you can define variable as a mathematical term which varies and used for representing an unknown quantity is called a variable. So now let me go for writing the definition of variable. Here I'll write a mathematical term which varies and is used for representing an unknown quantity is called variable. And you all know that every day we see the bad effect of that COVID. Many people are dying. Even in Karnataka also, you may be observing in the news channel that they are showing more than 1,000 people have died, 2,000. And is it predictable? No. Tomorrow what it will be? Today evening what will be the health bulletin? Right? It's not possible. Just we can say the number of people died because of corona. It is X. That is a unknown quantity. Can be represented by the mathematical term called variable. Example for this. Yes. Examples. You may go for taking any letter from English alphabet. A, B, C and so on. To X, Y, Z. Any of these can be taken. Okay. Now, let's move on to third term. Dear students, now I am going to take just one constant and a variable. I call this constant as 10. Variable as Y. We know how to multiply them. On multiplying, what you will get? You will get the product. Then if it is so, what is the product of 10 and y? It will be 10y. Is it not? Similarly, I am going to divide 10 by y. Then how do you, on dividing a term by another term, you will get quotient. What is the quotient of this? It is 10 by y. When you divide y by 10, you will get y by 10. Is it not? Yes. Here, can we say that this is the product of a constant and variable, right? And in this case also, you can observe constant and variable. These two are the quotients of a constant and variable. Then what do you call such mathematical term? Yes, it is called an algebraic term. What is an algebraic term? Yes, the product or quotient of a constant and variables is called an algebraic term. I am going to write this one. Algebraic term. Let me write the definition of algebraic term. Here I write a mathematical term, or you can write directly the product or quotient of a constant and variable. Maybe variables also. The product or quotient of a constant and a variable is called an algebraic term. Got it? Yes. Let me go for taking some of the examples. Examples are just, I'll write 7x minus 15y minus 8 by x square minus 15 m square n square, then AB by P, etc. All these are some of the examples for algebraic terms. I go for taking few more. 7 is an algebraic term. Y is also an algebraic term. Dear students, you all may be thinking that, sir, you are given 7 as an example for constant, y as an example for variable. Then how to say that 7 and y are algebraic terms? Let me give you the justification for this. Look here. Here I will take first 7. You all know that 7 can be written as 7 into 1. Then you just recall law of exponent. 1 can be written as anything raised to the power 0. Here I have taken x raised to the power 0. Then what do you call this mathematical term 7? Constant. X, variable. It is the product of constant and variable. If it is an algebraic term, what do you say about 7? That is also an algebraic term. Then can we say that all constants are algebraic terms? Yes. Next, I have taken a variable y, and y can be written as y into 1. You can also write it as y by 1. Then see that which mathematical term y is? Variable. 1 is constant. Here also variable and constant. What is the product of constant and variable? Algebraic term. Quotient of variable and constant? Algebraic term. If these two are algebraic terms, what do you say about y? That is also an algebraic term. Got it? From this, is it possible to say that all variables are algebraic terms? Yes, it is right. Now, I'll move on to fourth one. Observe carefully. Here I am going to take some of the algebraic terms. I take 7x square. Let me take 11x and 14. How many terms are taken? 3. I go for few more. Y raised to the power 4. Y raised to the power 3. 4 into y raised to the power 2. Then 3y and 14. Clear? Then again I go for taking one more. Z raised to the power 4 and 2. 2 terms are taken. Observe that. Here in first set I have taken 3 algebraic terms. You can go for connecting these terms by or joining these terms by using the symbols of any fundamental operations. What are the fundamental operations? Addition, subtraction, multiplication and division. You can go for using any sign. Here I am using plus, here minus. Here I go for using plus, minus, minus, plus. Here you may go for using plus or minus or division or multiplication, whatever you want. If you go for using multiplication sign, it will be 2 into z raised to the power 4. Division sign, z raised to the power 4 by 2. Plus sign, z raised to the power 4 plus 2. See that by joining these algebraic terms using the fundamental operations, we have got a new statement. What is that statement? That statement is called, each of these statements is called an algebraic expression. Got it? What is that? Algebraic expression. Here I'll write algebraic expression. Then how do you define an algebraic expression? Observe. If 2 or more algebraic terms connected by using the symbols of fundamental operations, then it is called an algebraic expression. Now I'll go for writing the definition. Here, if 2 or more algebraic terms algebraic terms connected or combined, connected by using what? Using the symbols of fundamental operations. Then it is called, what it is called? An algebraic expression. An algebraic expression. Okay. And these are some of the examples for algebraic expression. This is first one, and this second one, and this is third one. Yeah. Dear students, just by pausing the video, please copy from there to here. Yes. Dear students, I have taken few more examples for algebraic expression. See that? This is fourth one, x square plus 5x plus 6. Then here 1 by x square. Then this is root x plus 5. Then this is 2x raised to the power 3 by 2 plus 5x plus 2. And this is 4x raised to the power minus 2 plus 3 minus x. Then even just you may go for taking, here I'll write, a variable as an algebraic expression, a constant as an algebraic expression. Please do remember, all variables, all constants and all algebraic terms are algebraic expressions. Now, dear students, you are also very familiar with the numbers called integers, right? Give some examples for integers, or how do you write them? They are to be represented with I or Z, and they are to be written as 0, plus or minus 1, nothing but plus 1, minus 1, then plus or minus 2, plus or minus 3, and so on, right? Then if I ask you, tell about only the positive integers, how do you go for writing? Positive integers can be written as I plus, I plus, it is 1 plus 1 plus 2 plus 3 plus 4 and so on. If negative integers are there, they are to be represented with I minus, can be written as minus 1, minus 2, minus 3 and so on. Now, these are all positive and negative integers. If I ask you non-negative integers, how do you go for writing? Non-negative integers, they can be written as except negative integers, remaining are 0, 1, 2, 3, 4 and so on. Okay, they are all nothing but whole numbers. Okay, just know this information. Now, observe these. Here, whatever the examples I have given for algebraic expressions, I am going to make them into two groups. Call first one as A and second group as B. Now just I will give you a small one. You have to just think and recall the answer for my question. Observe the variables involved in these. Also their powers. Yeah, here power is 2, here is 1, here 0, because x raised to the power 0. This is 4, 3, 2, 1. Here power of the variable z is 4, it is 0. This is 2, 1, then here 0, here 1, here x raised to the power 0 is nothing but 0. So power is 0. Clear? Now, whatever the power you have observed, compare those with these 5 categories. Could you tell which one would you like to take? Whether they belong to only positive integers, only negative integers, or both positive and negative, or non-negative integers? Yes, you are right. The powers belong to non-negative integers. Now come across the algebraic expressions what I have written in the group B. Observe them along with the variables involved as well as their power. Here variable x, what about the power? When it is taken to the numerator, it becomes x raised to the power minus 2 then power is minus 2. Here root x can be written as x to the power 1 by 2, which we have already learned. Power is 1 by 2. Here power is 3 by 2, 1. Here minus 2, 1. Here is 0. Now what do you say? Do they belong to any category? Of course, some of them belong to, it is I or Z, this category, and negative integers are there. Even 1 by 2, 3 by 2, they are all fractions, nothing but rational numbers. Then do you say that the power of the variables involved in B group belong to non-negative integers? No, they are all not non-negative integers. And this group, these are the algebraic expressions involving the variables whose power is non-negative integers. They are called the name of our chapter. What is that? They are called polynomials. This is the actual definition of polynomial. Should be remembered. Don't think that if more than 2 to 3 factor terms are there, then it is called polynomial. That's wrong. It is actual definition of polynomial is an algebraic expression involving the variable whose power is non-negative integer. Is called a polynomial. What about here? The powers are not non-negative integers. These are called non-polynomial. Got it? Now, let me go for writing the definition of polynomial. Once you recall the definition of polynomial, and when I will be writing, just go on telling yourself polynomial, and this is also the name of our chapter. Here I'll write polynomials. Now let me write the definition. What is that? An algebraic expression involving the variable whose power is what is that? Whose power is a non-negative integer. Non-negative integer is nothing but whole number is called a polynomial. Got it? Yes. Once you go through the definition, an algebraic expression involving the variable whose power is a non-negative integer, nothing but whole number, is called a polynomial. So you can go for taking the examples of polynomial as these only. Just I'll take first one, only one example. That is 7x square plus 11x minus 14. Here, this is the polynomial. Do you know what we call 7x square, 11x and minus 14? These are all called terms of the polynomial. What are those terms? Here I'll write terms of the polynomial are 7x square, then 11x plus 11x, we have to include the sign. If plus is there, not necessary, but minus it is must. Minus 14. These are the terms. Observe here only the numbers. Here 7 is there, 11 is there, minus 14 is there, and these are called coefficients. What are those? Coefficients. Here particularly 7 is the coefficient of x square, 11 is the coefficient of x, and minus 14 is the coefficient of x raised to the power 0. Got it? Yes. Here I'll write coefficients. What are those? 7, 11 and 14. But 7 is the coefficient of what? X square. Then 11 is the coefficient of x. And minus 14 is the coefficient of x to the power 0. Understood? So now I am going to write the heading terms and coefficients of a polynomial. Terms and coefficients of a polynomial. Yeah. Dear students, earlier you had written up to this third example. Now you have to copy from here. Fourth one, then fifth, sixth. All these are algebraic expressions only. Then after that, you go for copying from there to here. Yes, copy. Just here, I've taken one simple example. Okay. Fill in the blanks with respect to terms and coefficients of a polynomial. Here I've taken 6 polynomials. In this, empty space is there. Here you are going to write the terms that are involved in each polynomial. Next, the coefficients involved, the corresponding coefficients involved. Okay? Yes. Go for telling yourself. Yes. First one. First polynomial is x square plus 2x. What are the terms? Yes, you are right. It is x square and 2x. Don't write x square plus 2x. Again it becomes polynomial. Next. What are the coefficients? Here. Coefficient of x square is, here nothing. It means there is 1. Coefficient of x is 2. Next. Come to second polynomial. 3y square plus 5y plus 7. Here the terms are 3y square. Should we write plus? No, because we are writing the terms, we have to write them separately. Next, 5y is there. What is the other term? 7. Tell the coefficients. Coefficients are 3. 3 is the coefficient of y square. 5 is the coefficient of y. 7 is the coefficient of y raised to the power 0. Here on y. It is 3, 5 and 7. Next. In third polynomial, the terms are minus x cube. Observe this carefully. Sign should be considered. Next, 4x square. It is second term. Third term is 7x. And fourth term is minus 2. Tell the coefficients. It is minus 1. This is 4. This is 7 and is minus 2. Got it? Next. It is fourth one. Root 3x cube minus 7x plus 15. Fourth polynomial. The coefficients, terms are root 3x cube. This is minus 7x and is 15. The coefficients are, it is root 3. It is minus 7 and is 15. Next. Fifth one. This is the polynomial. First let me write the terms. Terms are first term 5 by 3 x raised to the power 4. Next. Minus 11 by 2 x raised to the power 2 and 3. Then the coefficients are, it is 5 by 3. It is the coefficient of x raised to the power 4. There is no x cube. Next, x square is there. Coefficient of x square is minus 11 by 2 and constant 3. Next, x by 2 plus 5 by 2. The terms are, one is x by 2 and another one is 5 by 2. What about the coefficients? It is, look here, x by 2 is nothing but 1 by 2 into x, is it not? Hence, I'll write first coefficient, it is 1 by 2. It is the coefficient of x, and coefficient of x raised to the power 0 is 5 by 2. Got it? Yeah. Please go for copying this. Pause the video and copy. Dear students, just we have written the polynomials and the terms involved in that and their coefficients also. Right? And again, I've been taking the same examples. Observe this. In the first polynomial, how many terms are there? Here we have written them. There are 2 terms. Here there are 3 terms. Here, how many? 1, 2, 3, 4. 4 terms are there. Right? What about this? Here, 3 terms are there. Here, again, 3 terms are there. In the last polynomial, there are 2 terms. If I go for writing another one, 2x raised to the power 5. How many terms are there? There is only 1 term. Dear students, based on the number of terms involved in the polynomial, we can go for classifying them into different types. Let me tell you one by one. See, on the basis of number of terms, here, this is the polynomial having 1 term only. We call such polynomial as monomial. What is monomial? A polynomial having 1 term. And this is an example. That is an example. Come to this one. This is the polynomial having 2 terms. Hence, it is called binomial. A polynomial having 2 terms is called binomial. What about here? There are 3 terms. It is called trinomial. Here, 4 terms are there. Tetranomial. Got it? If more than 3 are there, in general, we say that they are multinomials. Look here, this one. 4th polynomial, it has 4 terms and it is an example for multinomial. Clear? What about this? It is trinomial because 3 terms. Trinomial, 3 terms. This is binomial. Got it? So, based on the number of terms, here I'll write. Based on number of terms, we can go for classifying polynomials into monomial, binomial, trinomial and multinomial. I'll go for writing first, one by one. In that first one is monomial. Monomial. What is monomial? A polynomial having 1 term only. Here I'll write. It is a polynomial having 1 term only. 1 term only. Example for this. It is, you may just go for taking any number. I have taken 2, any variable x, then any algebraic term 2x raised to the power 5. Many can be written. Next, second one. A polynomial having 2 terms. It is called binomial. Binomial. Here I'll write. It is a polynomial having 2 terms only. And example for that. Here I'll write. X plus 2. See, most of the examples I have been using the variable x. So, because you find it easier to follow. And next to further problems, we will go for using different variables. X plus 2, x square minus 11, then 2x raised to the power 4 minus 5 and so on. Many are there. Next, third one. A polynomial having 3 terms. It is called trinomial. Let me write the definition of it. It is a polynomial having 3 terms only. 3 terms only. Next, fourth one. So let me write the examples. Here, x square plus 5x plus 6, then x plus y plus z, 2x minus 3y plus 4. See, all these are examples for trinomial. Next, a polynomial having more than 3 terms. What it is called? It is called, could you tell? Yes, it is multinomial. Multinomial. Here I write. It is a polynomial having more than 3 terms. This is the definition of multinomial. Example for that, you can go for writing here x plus y plus z minus 5. See, 4 terms are there. Now x to the power 5 plus x square x raised to the power 4 minus x cube minus 3x square plus x, how many? 1, 2, 3, 4, 5 are there. Even you can write one more, 5. See the total 6 terms, more than 3 terms are there. Therefore, is an example. These two are examples for multinomial. Clear? Yes. Now, again, you just go through these polynomials. Whatever I have written, here I am going to write the terms. I am going to take only the polynomial. Here 5x raised to the power 4. Observe these polynomials and also the variables involved. Got it? Next, observe the power of the variables. You can 4, 2, 1, 2, 1, 0, 3, 2, 1, 0, 3, 1, 0, here 4, 2, 0, here 1, 0, right? Now, my question is, you are going to identify the highest power of the variable involved in each polynomial. What is the highest power of the variable? Here it is 4. What about this? Highest power. Here 1 is there, 2. Highest one is 2. Here I will write highest power. Next, I am not asking you number of terms. Highest power of the variable. Highest power is 2. Highest power of the variable is 3. Highest power of the variable is here also 3. Highest power is 4. Here highest power is 1. I will write one more polynomial, that is just 6. What is the highest power of the variable? 6 can be written as 6 into x raised to the power 0. Variable is x. Power is 0. Highest power is 0. Clear? Now, dear students, you may go for taking any polynomial. In that, whatever the highest power of the variable will be there, we call that highest power as degree of a polynomial. Clear? It's very important. Degree of a polynomial. What is degree of polynomial? A polynomial, highest power of the variable involved in the polynomial is called degree of the polynomial. Then what do you call these numbers? They are all degrees of these polynomials. 4 is the degree of 5x raised to the power 4. Next, second one. X square plus, the degree of x square plus 2x is 2. The degree of 3y square plus 5y plus 7 is again 2. Clear? So now let me go for writing the definition of degree of a polynomial. Here, very important concept it is degree of a polynomial. Just to recall the definition of degree of a polynomial. Here I will write the highest power of a variable, highest power of the variable involved in a polynomial. In a polynomial is called degree of a polynomial. Got it? Yes. Now observe this. These are the some of the examples. Here are right. First one, x square plus 2x. What is its degree? Here are right. Here. Degree is 2. Next, for this, degree is again 2. Here degree is 3. And for these, the degree of the polynomial root 3x cube minus 7x plus 15, it is 3. Degree is 3. Then this is degree 4. This is degree is 1. I'll take one more example, 7th one. It is as is 6. It is a constant polynomial. Constant is there and degree is 0. Do remember, the degree of constant polynomial or any real number, it is 0. Got it? Yeah. Please pause the video and copy from there to here quickly. Dear students, just I have taken some of the worked examples given in NCERT text. So this is the first one. Find the degree of the polynomials. These are the polynomials. How you are going to find out? Here, look here. X raised to the power 5 minus x raised to the power 4 plus 3. Degree is nothing but highest power of the variable. What is the highest power of the variable? Before that, first variable involved is x. Its highest power 5. Here 4 is there, here 0 is there. Highest one is 5. Therefore, degree is 5. Here are right. Highest power of x is 5. Therefore, the degree is 5. Here just they are not asked to write the degree. Find. So that we are finding how? By identifying the variable having highest power. Next, second one. 2 minus y square minus y cube plus 2y raised to the power 8. What is the variable involved? Y. And the powers are 0, 2, 3, 8. Highest one? 8. Therefore, degree is 8. Here all right. Highest power of which one? Power of y is 8. Therefore, the degree is 8. Next, third one. Now here all right. 2 is there. Dear students, you all know that 2 can be written as 2 into x raised to the power 0. Right? What is the variable involved? X. Power. It is 0. Hence, we can write the highest power of x is 0. Therefore, the degree is 0. Dear students, other than textbook, just I'll take one of the important question and you have to think and tell the answer. This is 1 by x into x square plus 3x. Could you tell the degree of this polynomial? Yes, what is it? Do you say that 2? Just think over it. And now I am going to write. You have to check yourself whether your answer is right or wrong. 1 by x into x raised to the power 2 plus 3x is there. Here denominator x is there. Do remember that. And each term of these two can be divided by x, or else in these two terms x is common factor. You can take out x. Then it will be x plus 3 divided by x. Now x and x get cancelled. It is equal to x plus 3. Dear students, observe that carefully. X plus 3 is there. Instead of that, they are just twisted. They are written in this way. You have to simplify. On simplification only, you will get x plus 3. Now you decide degree. Highest power is 1. Therefore, degree is 1. Here I write. And highest power of which variable? X is 1. Therefore, the degree is 1. Got it? Now, we will move on to the next part. This is also very interesting. Based on the degree only. Now, I am going to write some of the examples for the polynomials. You have to recall, you have to identify and tell the degree of those. Here I am writing x plus 2, then x square plus 5x plus 6. This is 7x cube plus 3x square plus 5. Next, x raised to the power 4 minus 11x plus 15. Clear? And one more. This is 5. Now I am asking you degree of these polynomials. First one, what is the degree? It is 1. Degree 2. Third one, degree is 3. Fourth one, degree 4. Fifth one, do you say the degree is 5? No, not possible, because it is just a constant. What is the degree of constant polynomial? It is 0. Dear students, based on degree also, we can go for classifying the polynomials into some types. Earlier, we classified the polynomials based on number of terms. Now, we are going to classify the polynomials based on their degree. Then you all may be thinking that, what do you call a polynomial of degree 1? Yes, it is called linear polynomial. Linear, straight. Afterwards, I will write them. Just concentrate here. A polynomial of degree 1 is called linear polynomial. A polynomial of degree 2 is called quadratic polynomial. A polynomial of degree 3, it is called cubic polynomial. A polynomial of degree 4 is called biquadratic polynomial. And a polynomial of degree 0 is called constant polynomial. Got it? So if it is more than 4, we say that quintic polynomial and so on. Many are there. Or polynomial with degree 5, polynomial with degree 6. Got it? Yes. Could you tell what is the basis on which the further classification of polynomial can be done? Yes, you are right. Based on their degree. Here I will write types of polynomials. Types of polynomials based on their degree. Based on degree. What is first one? A polynomial of degree 1. It is called linear polynomial. Let me write the definition of linear polynomial. Directly, I am going to use the third person, that is it. Here, in this case, it means linear polynomial. It is a polynomial of degree, how much? 1. Or a polynomial of degree 1 is called linear polynomial. X plus 2 is an example for linear polynomial. Dear students, please do remember, for these polynomials, linear, quadratic, cubic, biquadratic, we have the standard form or the general form. I am going to write that. General form of linear polynomial, it will be in the form ax plus b, where a is not equal to 0. Why? See that. A and b are the coefficients. Which are the coefficients are real numbers. Is it not? If a becomes 0, what happens? If a becomes 0, ax term get cancelled. Only b will remain. B is nothing but real number, nothing but constant. It becomes constant polynomial. Clear? When a becomes 0, it becomes constant polynomial. That is why this condition is must. I go for taking the example. You may just take only 2x is a linear polynomial. X plus 2 is a linear polynomial. Then 2x minus 5 is a linear polynomial. Dear students, often I have been telling you, only for the sake of making you to feel more comfortable, I am using x as a variable in most of the examples. In later part, we will go for using different variables also. Next, I go for taking second one. What do you call a polynomial of degree 2? It is called Yes, quadratic polynomial. Quadratic polynomial. Now let me go for writing the definition. It is a polynomial of degree 2. And general form of this, I am going to highlight this one. General form of quadratic polynomial is, please do remember, ax square plus bx plus c, where a is not equal to 0. Again, I will ask you a question. If a becomes 0, ax square term gets cancelled. Bx plus b will remain. Highest power is 1, nothing but degree is 1. It becomes linear polynomial. So, example for this, it is x square plus 5x plus 6. Then 2x square minus 11x plus 2, or only 2x square. Next, third one. What do you call a polynomial of degree 3? It is called cubic polynomial. Cubic polynomial. Yes. Definition. It is a polynomial of degree 3. Got it? Then can you tell the general form just by observing first two, ax plus b? It is ax square plus bx plus c. And what about this? Cubic polynomial. Its general form is, it is ax raised to the power 3 because it is cubic, plus bx square plus cx plus d. Again, what is the condition? A is not equal to 0. And example, it is x cube minus x square, 2x cube minus 11, then 3x cube plus x square minus x plus 2. All these are examples for cubic. Dear students, two more are there. What are those? What do you call a polynomial of degree 4? It is biquadratic polynomial. Can you write the general form yourself? Yes. Then, what do you call a polynomial of degree 0? It is called constant polynomial. And write the general form yourself and give examples. Okay. And tomorrow again I will go for writing those two. Dear students, pausing the video, you have to copy from there to here. And before concluding the class, let me tell you one thing. And today whatever we have covered, all concepts are very important, and I have given basics of this chapter. With the basics only I have started. Please be thorough about these concepts. Then further concepts will be very easier. Got it? So with this, let us stop. Thank you.